So I'm very happy to present you today our project on the usage of carbon, but which is for a long time known. So for myself, I'm professor for general analytical chemistry at the Montanuniversität Leoben, and as said before, me and my team are working on this particular project. So the idea of using carbon in agriculture is nothing new, but the thing which might be new and new to you is the source of the carbon. So the carbon which we are looking at is the carbon which is derived by hydrogen production. That means basically we are using methane and methane pyrolysis in order to produce hydrogen for using in industry. And this is the major project, is the decarbonization of industry. But of course, besides the hydrogen, we have a large amount of carbon, which is basically released out of this process. So what the process makes so interesting is that it uses about almost 90% less of the energy which you're using for electrolysis. But nonetheless, aside the large amount of hydrogen, which is nicely used, we have the amount of carbon where the question is what to do with this carbon, and not to use it as a waste, but to use it as a value material. So of course, there's a couple of applications in metallurgy or using carbon as graphite, as electrodes. But here we are losing the advantage of the carbon dioxide footprint, because basically we're then burning again the carbon dioxide. There are specific technologies where this carbon can be applied, especially considering novel materials. But of course, these are only minor areas. There are larger areas where larger amounts of carbon can be used is within construction. So similar as we have seen already with the concrete. Carbon can be used here as additional material, or maybe also in order to take up some heat and energy from the sun. But we are also having a large range of applications in the field of agriculture. And this is the part where I would like to focus on now, because considering the large amounts of fields and soils which can use carbon as fertilizer is tremendous. And the opportunities here are also very big. So considering carbon as in agriculture, as said, it's not a new thing. And we know about the terra preta, large areas in the Amazonian region, which were discovered. So hectares of soil with these terra preta, a mixture of coal, of peat moss, of some terracotta shreds and others, and also pointing out manure, which is equilibrated with these terra preta, which was used in the 700 to 1000 after Christ, but even before Christ, before our time, these materials were used, and they are still presenting a very fertilizing area of ground. So this is basically what is the product, and it is known that this terra preta stores nutrients, improves soil fertility, retains water, also is advantages to microorganisms, for example. So when we look at this type of carbon, which is basically biochar, then this has specific chemical compounds. So it is characterized by some polycondensed aromatic groups, and it has a very long biological and chemical stability. What is also interesting is that basically oxidation of the surfaces produced during the development process, during the thermal process, produces higher proportions of carboxylic and phenolic carbon on the surfaces. And these really have a very increased cation exchange capacity. So this becomes very important, very interesting to soils, of course. And this nucleus, which contains of aromatic compounds, remains unchanged even after thousands of years. So this makes these materials so interesting, and this in combination with the porosity of the material. So before talking about the advantages of putting carbon into soils, I would like to have a look on the carbon which you get out of from pyrolysis, which definitely looks a little bit different. And this is now the thing which is under consideration and under observation, that we know that depending on the process of thermocatalytic decomposition of methane, we yield different products from carbon black to nanomaterial type of carbon. And so this definitely already from the starting point looks a bit different to the biochar. And I'll get, so we had a look basically what would be the benefits of products which we receive out of thermocatalytic decomposition with respect of soil properties and fertilization products. So they especially having a closer look at carbon-based nanomaterials, which can derive in different forms. And one of those which becomes quite interesting are these nanotubes, which have specific properties, apply specific properties to the soil. So what is now happening if we would now go for applying this biochar and soil for improving soil quality? Of course, we don't have a lot of material yet and information. We don't have field experiments running right at the time, but so we start to compare to the positive effects of biochar on these soil qualities. So there's a couple of physical, mechanical, and chemical properties which can improve soil properties. For instance, like carbon storage. So carbon sequestration is one of the important things. The change of the pH and also especially the change of the cation exchange capacity with respect of fertilization and nutrients, improved nutrients, and also pollutant binding. So another part which has become interesting is the increased soil microbial properties, which can improve and which has also a direct relation to greenhouse gas emission, to a point which will come in a couple of minutes. So one thing which has become also interesting is also the consideration mixing this carbon with manure and other organic materials. So getting the fertilizers out of the manure, giving it to the soil via the pathway of the carbon. So if we have a close look at nanocarbon, especially because this would be one of the materials which we can think of getting out of these pyrolysis processes, especially increased water holding capacities is one of the areas which becomes very important, considering also that the large areas of soil become dry, and dryness is an increasing problem also with relation to climate change. And of course, mechanical soil stabilization becomes interesting, especially considering erosion processes also linked to climate change. And of course, chemical characteristics like pH, nutrient losses, and absorption of surfaces of contaminants can be a factor which is positive to soils. So increased soil fertility, increased nutrient cycling, and mitigation of climate change are the major targets when considering using this type of carbon on soils. And of course, microbes and their activities were also considered and observed. And we do see changes of the microbial communities when using nanocarbons in soil, which is neither positive nor negative. So these effects have to be studied in detail, what this basically means at the end of the day as an effect of the fertilization of a project, of a process. So the other thing which happens is, rather than using the carbon which is derived from TCD of methane directly, we can change its properties. So on the one hand, of course, we can change the process in order to get different types of carbon and to see what is the most positive type of carbon which we need in order to improve soil properties. But also we can do some post-processing, considering like simply mixing the carbon with manure, as indicated before, to getting the nutrients out of the manure, but also considering the large amount of manure which is produced in intensive agricultural products processing, like animal farms or similar. The surfaces, the biochar itself can be activated with microorganisms, and also considering coating fertilizers like urea with this carbon, which leads to a release of the fertilizers in specific time zones. So considering the usage, though it's on the one hand having carbon as a large amounts of carbon to be used in agriculture on the one hand, we have to look at the effects of this carbon aside from a positive effect using it in agriculture. So storing it in the soil is basically more or less dumping, but we do see that it has a positive effect on soils, but also it has definitely a high potential for saving greenhouse gas emissions. So considering Austria, where we have a natural gas consumption about 9 billion cubic meters. So this would yield 4.5 million tons of carbon. So considering that we can use 60 tons of carbon per hectare, so we have 74,000 hectares. This is about 5% of the total agricultural land. So we have large areas with which we can put this carbon on, and also considering that a substantial part of this land, which is used in agriculture, is carbon deficient. So considering a degradation rate of about 2%, so we can see how this carbon can be accumulated and further used. Another point which has become important is the consideration of reducing emission of nitrous oxides. So here again, we have a high capacity of carbon dioxide equivalents which can be removed. So just to sum up shortly, in order not abusing my time, we do see a high potential of using this biochar. A lot of considerations and experiments have to be considered, have to be done still, but nonetheless, it has a very high potential, an important avenue for future carbon sequestration and reversing the decline in soil fertility and associated desertification. So with this, I would like to thank for your attention, and I'm happy and open for questions.